This simple idea of a wood Pyrex container lid has taken me over a year to really refine and get right. And this project started out with my frustration of the traditional plastic Pyrex lids, which will eventually always start cracking, failing, and falling apart. And if you have these lids, you know what I'm talking about. I also just like the idea of having less plastic stuff in my life. So about a year ago, I started out with my experimentations to make a pure wooden lid that would fit on the Pyrex container. And the idea in this first version was to have these little nubs that would sort of latch onto the outside of the lid and help it lock on. And really what I was doing was taking advantage of the fact that these Pyrex bowls are not perfectly circular. They're just slightly oval. And so that means the lid can fit a little bit loose in one spot, and if I rotate it, it will tighten itself and not fall off. Now, this idea has two fundamental flaws. And the first flaw is that these little nubs will eventually break off, particularly if they're aligned parallel with the grain. They tend to just easily snap off. But the other bigger problem is warpage. The wood will tend to cup and warp, particularly in a really humid environment, like next to food inside of your refrigerator. And so that warpage would make the lids just not fit at all, or worse, the wood will actually swell, and then I can't even get the lid off without a lot of force, which is not great. So I need to solve two problems: how to make the lid latch on really tight, and two, how to actually make the lid not warp. So I first decided to focus on how to make the wood not warp. Now, if you are a woodworker, you're probably familiar with how wood behaves when the moisture content will change. And basically what I like to think of is if a tree is growing upright, that the tree will get fatter or skinnier depending on the moisture content. So that means that a board where the grain's running vertical will get wider or skinnier along this direction. And that will tend to cause the wood to cup and to warp. And one of the typical ways that woodworkers will prevent warpage from happening or cupping is to have a piece of wood go the other direction. Now, there are considerations with this. You can't just glue another piece on because the warping will actually make it crack and fall apart. And the way this is done is usually with mortise and tenons, and this technique is usually called a breadboard end. It works great on tables, but I don't think I can do a breadboard end on something that's circular like this little lid. But another way to prevent warpage is with a sliding dovetail. So let's try that. And before I dive too deep here, I will have files available for these, so if you want to try to make them, they'll be available on my website, so you can make them with a CNC machine. You'll probably also need a 3D printer and some custom bits, which we'll talk about. And this project's really cool because there's almost endless customization possibilities by V-carving something on the top to make real custom containers for people that you might be able to sell really easily at craft fairs and whatnot. Now, I did the main design inside of Autodesk Fusion and all my toolpaths, but I know a lot of people like Vectric VCarve, so I recreated all the toolpaths inside of that application for those of you who want to use that app. Fusion allowed me to really carefully model everything up, including the sliding dovetail that I had to do first. The simulations are incredibly powerful in Fusion, and you can really find out if you're going to have any collisions or issues before you actually machine anything. And it will show undercuts with dovetail cutters, which Vectric won't even do. I like to use my 3D printed hold downs to hold down my workpiece, and the idea is to eventually leave tabs. Now, these are great because if you hit them, it's not really that big of a deal. The most important thing is to make sure that the wood grain is going to be perpendicular to the travel of the sliding dovetail slot. And if you watch my first roughing cut that I did, I'm using a 1/4-inch upcut bit, and as it exits the workpiece, it produces a lot of chip out right there. As it comes back in and exits the workpiece, it also produces a little bit of chip out, but not as much. The dovetail bit comes through and does a finishing pass to clean up the part the upcut bit left fuzzy. But I would like to fix that chip out that I got. Now, realistically, getting a little bit of chip out on the backside of a project like this isn't a big deal because the main part of the circle isn't going to be affected by it. But it is nice to figure out how to fix something like this when it might actually apply to a particular project. And it's not too hard to fix inside of Fusion. You can customize some toolpaths to do a little bit of a back cut first, and that will almost eliminate it. I didn't do it in the Vectric VCarve file, but inside Fusion I did it just for fun as an example. And realistically, the best way to avoid chip out is probably to support the piece in the back side so you don't blow it out. The next thing I had to do was figure out how to cut the actual sliding dovetail shape that was going to go into it. What I decided to do was to rip some strips that were 5/8 of an inch thick, which is just slightly thicker than my actual dovetail slot, and at a 1/4 inch thickness, which is my final thickness for it. I struggled with finding a good way to hold down the workpiece because it was so small and thin. I tried double-sided tape directly to my work table. I tried blue tape and CA using a small sacrificial board, and ultimately what I settled on was putting double-sided tape on top of a little scrap piece. I realized that my little 3D printed tips on my hold downs could just be sacrificial pieces, and I could completely mow through them and basically make a custom little hold down, not worrying about them. And this is just a basic profile toolpath in Autodesk Fusion or Vectric VCarve. And I needed a quick, consistent way to make these because my first one was just way too loose. I wanted to have a tight fit. And it's pretty easy to adjust the fit. Inside of Fusion, you can adjust the radial stock to leave. If you make the stock to leave larger by a few thousandths of an inch, it will make it tighter. If you make it smaller or negative, it will make it looser. And inside of Vectric VCarve, this is called the allowance offset. It works the same way. And it took me 3 or 4 tests before I finally got to that nice fit that was tight. And back to that wood movement thing, I wanted a dab of glue in the middle and only in the middle. So I tried putting it on the top for my first one. And that seemed to work, but what I later ended up doing was to push the sliding dovetail in halfway, add a little bit of glue to the middle at that point, and then push it in the rest of the way. And this might get glue in a few spots where it shouldn't be, but it doesn't seem to be a big deal based on my testing. And so the question is, will this really work? And it seems to be working. This is a raw piece which has a sliding dovetail on the bottom side of it, and I soaked it in water for quite a while, a day, and then I put it in the fridge, and I could observe how the piece was actually swelling up and getting wider here, but the little dovetail portion was staying the same length because of the orientation of the grain, and it wasn't really warping. It warped a little bit, but not nearly as much as the other ones. So I think this is a viable solution. One of the questions I asked myself is, should I put the dovetail on the bottom, the inside of the lid, or the top? And I explicitly chose to put it on the bottom because I want to do designs on the top. So yeah, that's why I did that. At this point, I had to decide what bits to use to cut out the shape. It's a really simple circular pocket and then a basic cutout leaving tabs. The pocket is best suited to a downcut bit in order to leave a clean finish on the top of the wood. The cutout would be best with a compression bit, but the material isn't thick enough at that point, so a downcut bit would also be fine. So the next thing I had to figure out was how to actually make the lid stay on, because you want to fairly easily go on, you don't want to fall off, and you also want it to be tight enough where you can grab it and lift up the container with it. So this one's way too loose. It kind of stays on and kind of seals, but it just too easily falls off. You want to be able to quickly push it on, be able to grab from the top of the container, and not have it fall off. As humans, we tend to grab things from the top lid and kind of carry things around. You also want it to be fairly easy to take off. So some of them, like this one, is a little bit on the tight side. I can still get it off, but it takes a little bit of force. So I would like it a little bit looser. And so I wanted to use some type of gasket to hold it together because I'm not reinventing anything. Other people have made these with gaskets. But how can we make those at home? Well, with 3D printing, we can do lots of cool stuff. And there's a material called TPU, which is a soft, flexible plastic that I decided to play around with. Now, the thing about TPU is not all TPU is the same. I have a bamboo printer, which has a AMS feeder on top. And there's a particular type of TPU that Bamboo makes for this feeder. And is called the AMS TPU. So this white material is printed from that. And it is kind of soft and flexible like a gasket, but it's a little bit too strong. It's a little bit not flexible enough. If I kink it like this, it tends to hold its shape. Now I have another TPU that's a much softer one, and I'll put a link to it. This one I printed on my older bamboo printer, which pretty easily feeds it in. Didn't have to do anything weird with it, because TPU is sometimes hard to print. And it prints really easily on my older printer. It's much more flexible. If I squish it on up and let it go, it pops back to its regular shape. Now, of course, with anything that's wood and plasticky like this, you aren't going to be able to put it in the microwave or the oven, but that's fine with me. Now, one of the biggest problems I had to figure out for this project was how could I cut a slot for that gasket? So my first crazy idea was just take an old Dovetail bit and see if I could make a custom form cutter that I could use to cut the slot. And it seemed reasonable, maybe that'll work. So I took it over to my grinder and started grinding it a little bit, and I quickly realized carbide is really hard. And if you don't know, that little bit of extra metal that you'll sometimes see glued to the end of bits is tungsten carbide, and you probably need a diamond bit or a diamond wheel to actually grind it away, which I don't have. For old lathe users, cutting custom cutters is pretty darn common. I used to do a lot of metal machining, and I have a whole bunch of old dull cutters made from high-speed steel, and HSS high-speed steel is pretty easy to shape and cut. I could grind the basic shape away on my grinder and then use my Dremel with a metal grinding wheel to shape it down a little bit further. And finally do a little bit of stone work in an attempt to make it a little bit sharper. So I ran this homemade cutter on my CNC machine going really slow with both a feed and a speed, and to my surprise it actually cut pretty well. But after some experimentations with actually putting in the gasket, I figured out that the slot just wasn't deep enough. And so this cutter really just wasn't going to work well enough. I really had to use a real slot cutter. Unfortunately, I really wanted to use tabs to hold down the workpiece on the CNC machine. And if I used a slot cutter, I would need a larger and larger area for the cutter to actually fit into to avoid hitting anything. Now I could hold things down differently, like I could use double-sided tape, but I really didn't want to do that. I wanted to have tabs and make it really simple to do. This is a slotting bit from Whiteside that produces a 1/16 of an inch kerf, which would be just about perfect for this project. So the bit has a bearing which allows you to really easily cut a slot, but it's at a predefined depth, and with my first initial tests, I could actually just snap off the pieces because the slot was a little bit too deep. So I need to go not quite as deep and or have a thicker piece of wood behind the slot so it wouldn't break as easily. You can pretty easily adjust the depth of a slot with a different bearing, but I didn't want to wait to get a new one. And so I just made a quick jig, a couple pieces of MDF super glued to another piece that I could then clamp to my table saw as a fence, and I could move my actual table saw fence really precisely to adjust the depth of the slot fairly easily. And so at this point I kind of had the process down, and I just had to experiment with different thicknesses and different depths of wood for how deep it would actually go into the bowl and provide a good seal, and different actual sizes of gaskets. So I ended up printing lots of test gaskets to figure out which ones work the best in most situations. And now it's time to do the fun part of engraving cool designs on the top. There's some tricks I do, and first of all, my size is pretty well known, so I can just take it and flip it from, I just cut this side, I can flip it over. I can orient my grain depending on how I want it, either vertical or horizontal, depending on what works best with the design I'm doing. And I can not cut it out of the tabs yet, use this as my origin, and then I don't have to find the origin again. Don't have to reset anything in my machine. I can clamp it down. If I want the design to stand out a lot, I will probably add a little bit of a stain to it. Sometimes I will pre-finish this a little bit with some of the cutting board oil that I use for my finish. Then I'll engrave it. It'll expose clean new wood which the stain will stick a little bit more to. And then I can sand the stain off, or just leave it as is, or stain the entire top. There's lots of options that you can play around with. So you can get a lot of different effects depending on how you do things and how the wood has aged over time. So this one's a year old, and the cherry is a lot darker. This one doesn't have any oil on it yet, just some stain, no stain, just oil, a light coat of stain, and oil. For doing the actual VCarve, I make them at about 20 thousandths or 25 thousandths of an inch deep, and that seems to be deep enough to kind of leave a nice effect. You can do it all inside of Fusion. I've been using my plugin VBit Inlay to do the toolpaths for this, which makes it really fast and easy. The designs, I usually use a combination of Illustrator to actually make the designs themselves. And before I wrote my plugin, I was using Vectric VCarve. That works great for doing VCarves, obviously. So after a whole lot of iterations and a bunch of testing, I'm pretty happy with how these are fitting now. I have two gasket sizes that I tend to like using, and you can print them up and see which one works best for your particular case. I found that a lot of the Pyrex bowls, these are the small 2-cup ones, they kind of vary in sizes slightly. Anyways, this was a pretty fun project. Thanks for following along. Post questions about my process. I will have the files available both in Fusion and Vectric VCarve, and you can download a copy and check them out. I'll put some links in the description where we can get stuff. Bye, thanks everyone.